In this paper, we present Lumos, a visual analysis tool that models a user's analytic behavior from prior interaction history with the data to increase awareness of unconscious biases during analysis activities. Lumos captures the user's interactions with attributes and data points, and leaves behind a visual footprint known as interaction traces, highlighting the attributes and data points that the user has been focusing on so far. For example, in this demonstration with a movies dataset, I have created a scatterplot visualization of production budget and worldwide gross, and filtered it for PG movies that have an IMDb rating above 7. Lumos shows users their interaction history in a few ways. First, Lumos highlights data points that the user has already visited in situ by updating their coloring from white to blue depending on their interaction frequency. That is, the number of times that they're hovered on. Second, Lumos also highlights the attributes that the user has already interacted with in the attribute panel by updating their coloring using the same white to blue color scale depending on their interaction frequency. That is, the number of times that they're used as encodings and filters. In addition to these in situ interaction traces, Lumos also shows ex situ interaction traces in the distribution panel, making users aware of how their interactions compare to an underlying target distribution, in this case compared to the underlying data distribution. A red background color of the attribute row indicates that my interactions deviate from the underlying data distribution. Let's expand this red creative type row for a closer inspection. The visualization shows that my interactions in blue are skewed heavily toward kids' fiction and fantasy movies, even though the data in black shows that the dataset is comprised of several other creative types, for example, contemporary fiction, that I haven't focused on. Let me now explore some contemporary fiction movies. As we can see, the blue bar in the distribution panel has risen, making the user aware of the shift in focus in real time. On the other hand, a green background color of an attribute indicates that my interactions are similar to the underlying data distribution. For example, the black curve indicates that most movies have a running time between 60 and 140 minutes, with an average of around 100 minutes. And my interactions in blue are somewhat similar to the data distribution. To facilitate visual data analysis, Lumos currently supports strip plots, scatter plots, line charts, and bar charts. Let's create an aggregate visualization, a bar chart of average worldwide gross across genres. As we can see, the bars are already colored in different shades of blue, representing my focus across the underlying data points that make up each aggregated bar. Hovering on a bar shows the underlying data points belonging to that bar in an interactive tabular visualization in the details view below. The rows in the table use the same white to blue color mapping to represent frequency of interaction with each data point. We conducted a qualitative experiment with participants using the Lumos interface either with or without the interaction traces to explore a dataset of movies. Our findings suggest that Lumos increases a user's awareness of their visual data analysis activities in real time, making them consciously reflect upon and acknowledge their intentions. This can lead to future changes in behavior and, in some cases, influence the decisions made from data. These results can have far-reaching implications toward mitigating biased analytic behaviors in decision-making contexts, such as aiding a hiring committee to meet their gender targets, and generally fostering more transparent analysis processes. Lumos is available as open source software at github.com/lumos-viz. For complete details and data analysis, please read our paper.